Hello, and welcome to section 5.3, Functions and Relations. Really, I like to think of the word functions as functions because this is a really fun section. And just a reminder, I don't really go over the summary too much. That's something that you should definitely read on your own. There's really not a lot of filling in part for that. So you should definitely take some time to read the summary before you watch the video. All right, but I do like to get started on the actual notes part. So we're going to start with the definition of a relation. That is a set of ordered pairs. X, Y is called a relation in X and Y. The set of X values in the ordered pairs is called the domain of the relation. The set of the Y values in the ordered pair is called the range of a relation. Then we also have the definition of a function. Given a relation in X and Y, we say that Y is a function of X if, for each value of X in the domain, there is exactly one value of Y in the range. I like to tell my students that what this really means is that your X's cannot repeat in order for it to be considered a function. And so there's many different ways we can see ordered pairs. We can see them on a graph. We can see them listed as ordered pairs. We can see what we call, mapping. But I'm basically just looking at my X values. I want to make sure that they don't repeat. And so here on number 1, I have 2, 3 and 2, 4. My X's repeat. So it says determine if the relation defines a function. This would be not a function, because the X's repeat, and it is not following that rule that for each X in the domain, there's exactly only one Y value in the range, since we have 2, 3 and 2, 4. Let's take a look at number 2. I have 1 for my X value, 2 and 3. Okay, that's good. I did not have any repeats, so yes, this would be considered a function. And then mapping is very similar. I just have to kind of look at these arrows. So for example, -2 is being mapped with -2. So that's what that ordered pair would look like. 6 is being mapped with 6, and pi is being mapped with pi. Notice that all of my X values are only going to one Y value. So yes, this is a function. Once again, the X values are not repeating. So you're probably thinking, well, when is it not a function for mapping? Well, if you take a look at number 4, I see 0, which is only going to one value, 1, which is only going to one value, 3, but oh no, 6 gets to go to two values. That would make it not a function. All right. Well, the good news for us is we have what we call a vertical line test that will help us to determine if a graph defines y as a function of x. Basically, the rule is no vertical line can intersect the graph in more than one point. All right, so I'm going to take a vertical line across my graph, and notice it is crossing in more than one place. That means that it is not a function when that happens. All right, now on number 6, when I draw my vertical lines across, or if you can imagine taking a vertical line across, notice my vertical line is only intersecting in one place the whole time. So yes, this would be considered a function. And then for number 7, it appears that it's going to be a function until I get to this part. And notice it's crossing in two places. And so this would be not a function. All right, let's move into some function notation. So for function notation, if you recall, we are going to take the values given and we're going to evaluate this function for those values. For instance, I have f at -3. I'm simply going to replace x with -3. That's really what this is saying here. It's saying take your number and replace your x. And so I'm going to do this. And one thing I always encourage students to do is to use parentheses anytime you're evaluating. So I'm going to plug -3 in, and this is like my little skeleton. And notice I am going to use parentheses because if I don't, it's possible that when I do negative 3 squared, I might get it incorrect. But the value negative 3 squared does become a positive 9. Now from here, you have options. You can work this out by hand or you can use a calculator. It's kind of your choice. Honestly, I would probably encourage you to do both. And you should end up with 19. All right. Now for F and A, this always confuses students, but the idea is the same. I'm going to replace x with a. And from here, I can't really do anything else. So this would just become a squared minus 3a plus 1. And then this next one is actually quite difficult because what happens is we have this binomial x plus 3, right? So we're going to replace all of that, the x's, with x plus 3. Do this in red. Well, this actually is going to require some work, right? Because over here, when it was just a, there was nothing really for us to do. It was just 3 times a and a squared. But this is actually the quantity of x plus 3 squared. So essentially, it's x plus 3 times x plus 3, right? And then you might remember here, we're going to use the distributive property, which is where we have to multiply the negative 3 by both parts. That would be negative 3 times x is just negative 3x. Negative 3 times positive 3 is negative 9. And then that plus 1 is just going to drop down. So I have to do some simplification here. In fact, I'm going to have to multiply this out. There's many ways you can do that. You can do the FOIL method. You can do the box method. It's kind of your choice. I am going to just do the distributive property, which would just be x times x. That would be considered the first if you were FOILing. And then I'm going to multiply x times 3. That would be the outer part, so positive 3x. So essentially, I just took care of this x value. And now I need to do the positive 3, which I'll do in red. So positive 3, now I'll have to multiply positive 3 times x, which is positive 3x. Positive 3 times 3 is positive 9. And then notice the other part just kind of drops down here. Ooh, it's a workout. Now I have to combine all of my like terms, which I'm going to highlight for you. All right, so I have a positive 3x, a positive 3x, a negative 3x. Those are all going to get to go together. They're all x friends. And then my numbers will also combine, right? You combine your numbers. Like if somebody asked how old I was, I wouldn't say I'm 35 plus 6, right? I would just say I'm 41. So I can combine my numbers as well. All right, so the x squared just drops down. It doesn't combine with anything. Positive 3x plus 3x is 6x. Minus 3x is positive 3x. All right, so this became a 6x here, but then I had to do the minus the 3x, which is how I ended up with a 3x there. Then for my numbers, let me do this in green. I have positive 9, minus 9, what? Okay, that cancels out. And then plus 1. So that plus 1 would just drop down. Whew, all that work for one little problem, right? But it's an important problem. All right, we're now going to evaluate another function, and then we'll talk about domain and range. All right, so for this one we have evaluate g of x equals the square root of 6 minus 2x for the given values of x. We're going to start with g at 3. Remember, all I'm doing is placing the values in for x. And so it's going to be 6 minus 2 times 3, right? And remember, order of operations, there are invisible parentheses inside of this square root, all right? Just FYI, they're just invisible. So I do need to go ahead and do the 2 times 3 first. So this is going to be the square root of 6 minus 6. 6 minus 6 is 0, right? Because 2 times 3 was 6. So 6 minus 6 is 0. The square root of 0 is 0. And I can also check that with my calculator. For g at 4, I have the square root of 6 minus 2 times 4. 2 times 4 is 8. So I end up with 6 minus 8, which is the square root of negative 2. Well, if you try to do the square root of a negative in your calculator, it's probably going to tell you it's undefined. And I'm just going to say for now, because later on in the future we can actually do other things. But for now, we're going to say it's non-real, it's undefined. All right, and then g at negative 4 is 6 minus 2 times negative 4. And that part I would have to do first. 2 negatives make a positive. It becomes 6 plus 8. 6 plus 8 is 14. So that would be the square root of 14. If I try to do that in my calculator, it would probably give me a decimal. All right, so what I'm going to do, because this video is becoming very long, is I'm going to make a second video for the second part of 5.3. I'll probably call it 5.3 part 2 or something. But I hope this video helps you so far with section 5.3. See you soon.